Hey guys, so today we're going to be doing the quotient rule. The quotient rule is really important, and I know I say that because every, derivative rule is important, but it comes off more complicated than the product rule or any rule you've seen earlier. That's because it's got more terms and more things going on, and people just get confused by it. So we're going to leave this video being experts at the quotient rule. I'm going to break it all down, and we're going to do some examples, and we're just going to leave, we're just going to leave this video knowing the quotient rule like the back of our hand. So let's get started. So what is the quotient rule? Well, the quotient rule is a rule for finding the derivative when we're given a function divided by another function. So what do I mean? So say I have, for instance, h of x. And that is f of x divided by g of x. So I got a function divided by a function. I have f of x divided by g of x. So f of x is being divided by g of x, and so I got a function divided by a function. And I want to find h prime of x. I want to find the derivative of this thing. And the quotient rule helps us do that. So what is the quotient rule? Well, now that we've identified when to use the quotient rule, actually let me take a step back. So for instance, we have f of x divided by g of x. It could be something like this. So x squared over sine x. We have something like that, and that's cool. And this is when we use the quotient rule. So what is the quotient rule? Well, say we're trying to find h prime of x. So the quotient rule says that, well, looking at this expression, the numerator is f of x and the denominator is g of x. So the quotient rule says the following. The quotient rule says f prime of x, so the numerator, the derivative of the numerator, f prime of x, times g of x, the denominator, minus g prime of x, the derivative of the denominator, times f of x, all divided by g of x squared, gives us h prime of x. This is the quotient rule. So, well, we got a lot going on here, but what does it say exactly? Well, it says that we have this numerator. Our numerator is f of x. Our numerator could be anything else. It could have been t of x, s of x, but the important thing to keep in mind is we are talking about the numerator. So in this case, the numerator is f of x. So follow this with me. So the first thing we do is we take the derivative of f of x. So we get f prime of x. Then we multiply it by the denominator, g of x. In this case, it's g of x. So we take the derivative of the numerator and multiply it by the denominator. Then minus g prime of x, which is the derivative of the denominator, times f of x, which is just the numerator, not the derivative of the numerator, but just the numerator. Then we divide this whole expression by the denominator, not the derivative of the denominator, but the denominator squared. We take the whole denominator expression and we square it. And that gives us the derivative. So in this case, that's h prime of x. So it tells us how to find the derivative of something in this form, where we have a function divided by another function. So as I did with the product rule, what we're going to do here is we're going to reparameterize. We're going to make this expression of the quotient rule look much neater and easier to work with. So let's do that. So we have our h of x in this case, and this could have been t of x, and same for this. This could have been like s of x. It doesn't matter which letters you choose. Just it's important to remember the concept. This could have been like u of x. So what we're going to do, this is frequently we're going to choose f of x to be equal to u and g of x to be v. Just like we did with the product rule, we're going to reparameterize this, and we're going to say u is equal to f of x and v is equal to g of x. And let's write down our expression for the quotient rule. So the quotient rule told us take the derivative of the numerator, multiply it by the denominator, minus the derivative of the derivative of the denominator times the numerator, all divided by the denominator squared. Well, we're reparameterizing, so we're going to say u is equal to f of x and v is equal to g of x. So u is equal to f of x, and that is equal to the numerator, and v is equal to g of x, and that is the denominator. So, well, we got u and v. And keep this in mind, the numerator and the denominator. So u is equal to f of x, and that's equal to the numerator, and v is equal to g of x, and that's equal to the denominator. So what's u prime? Well, let's find u prime. We need u prime. Well, u prime is f prime of x. And v prime is g prime of x. So let's sub that all in. We got all our pieces of the puzzle. Let's substitute them all in. Well, we got h prime of x. So what's f prime of x? Well, f prime of x is just u prime. G of x is just v. You got minus. What's g prime of x? Well, g prime of x is just v prime. And what is f of x? Well, f of x is just u. And this whole thing is divided by g of x squared. Well, what's g of x? Well, g of x is just v. And we're going to square that, right? Because we have the square term here. Don't forget that. A lot of people they tend to forget that last part where you got to square the denominator. And there we go. We have our reparameterized and much better looking quotient rule. And a lot of professors, they tend to do this. And reparameterization is just very important. It's very good practice for future calculus too. Future calc classes, you'll be doing more parameterization, reparameterization. So you need to get comfortable with this idea. And this is very good practice if you just, keep doing this over and over again. So you really want to get comfortable with this reparameterization because it looks better. It's neater in your head. It's got a nice ring to it. If you read this out, you got u prime v minus v prime u divided by v squared. That's got a better ring to it than f prime of x times g prime of x minus, going on. That's much longer, and it takes up less space in your head. So keep that in mind. Get comfortable with it. So let's move on to an example because now we've seen it. We've seen the quotient rule, but we haven't seen it in action. So let's see it in action. So our first example probably looks very familiar from the limit section, but this time we'll be taking the derivative of it instead of finding the limit. So first example is sine x divided by x. And we're going to find the derivative of this expression. So looking at it, what are we going to use? We look at this expression, well, which rule do we use? It's, you got to identify which rule to use. And in this case, we got a function divided by a function. And what we're going to do is we're going to use the quotient rule. So we're going to say sine x is equal to, I'm going to stick with the f of x and u notation. I'm going to use them both in this question. Then I'm just going to abandon the f of x and g of x notation, and we're just going to stick with the reparameterization. So in this case, I'm going to say sine x is equal to f of x. And that's equal to u. And actually, I'm going to write this the other way. So I'm going to say u is equal to f of x. That's equal to sine x. And I'm going to say v is equal to g of x, and that's equal to x. So what does our quotient rule say? Well, it says y prime, the derivative, is equal to, it's equal to f prime of x times g of x minus g prime of x times f of x all over g of x squared. And you always want to make this, you want to specify which one you're calling what, right? So you want to make sure you write that down before you actually start the question. And I always do that because, it just looks like nice and neat when we find u prime and v prime, or f prime of x and g prime of x. So I wrote down this version. I'm going to write down the reparameterized version. So u prime v minus v prime u over v squared. So you need to understand it's not just about memorizing this. It's about understanding the terms and what you're doing here. So, like, if we go back to the last slide. An easy way to understand this, remember this in a way, is that why do we take the derivative of the numerator first? Well, because the numerator's on top. And, you know, we use that kind of as a memory trick. You could think that, you know, you might think, oh, which one do I take the derivative of first, the numerator or the denominator? Well, the numerator's on top, so, you know, you're going to start with that. You're going to take its derivative first, and then you're going to multiply by the denominator, then minus the derivative of the denominator. So now you're taking the derivative of the denominator. It's the denominator's turn to have its derivative taken, times then the numerator. So you're going to kind of work, you know, top to bottom. So let's go back. So we wrote down our reparameterized version 2, much neater. So, well, let's find u prime. Let's put all the pieces of the puzzle together. We have our rule. We've written it down. So basically, we just got to put the pieces together. So let's find u prime. Well, what's u prime? Well, u prime is f prime of x. And what's that? Well, that's just the derivative of sine x. And the derivative of sine x with respect to x is just cosine x. Right? So let's do the same thing. Let's find v prime. What's v prime? Is g prime of x. And the derivative of x, so g prime of x, the derivative of x is just 1. So we're done, basically. We're just got to put all the pieces together. So what's y prime now? Well, putting all the pieces together, well, what's u prime? Well, u prime is f prime of x. And what's that? That's cosine x, right? So I like to put this in brackets. It's good for beginners to put each term in, each function in brackets. You know, putting u prime in brackets and v in brackets, just so they can look back and see their work, you know, examine it clearly. So when you're starting off, you should do that. Get more comfortable with it, then, you know, you can ditch that. But it's very good to do that when you're starting out. So we're going to put that in brackets. So u prime is cosine x. So that's in brackets. So we got one piece of the puzzle. Our next piece of the puzzle, what's v? Well, v is just x. Now we got minus, so we got that first term down. So minus. Now what's v prime? Well, v prime is just 1. We found v prime, right? So that's just 1. What's u? Well, u is just f of x, and that's just sine x. So there we go. We have that part done. So now, well, we got v squared. So what's that? Well, what's v squared? Well, it's just g of x squared. So what's g of x? G of x is just x, and we square that, so we just get x squared. So we're done. So if you simplify this just a bit, you just get x cos x minus sine x all over x squared. Done. So it's just a matter of knowing when to use the quotient rule. You know, looking for a function divided by another function, you know, and then, you know, writing out the quotient rule and then just finding the terms and just putting the pieces of the puzzle together. It's not more complicated than that. It's quite easy. So let's go on to the next example, which is a little more complicated. So let's take a look. So we're given a function. We got y is equal to, we're given, I'll write this down here because it's a bit big. So y is equal to x squared plus 3x plus 1 divided by x squared plus 2 plus 2x e to the x minus 1 over x. So looking at this, we know we got to use our sum and difference rule. We have to take the derivative of each term on its own, right? So then put it all together. So let's work with this first term. You know, let's start here. Let's separate from, you know, this whole thing and then just take the derivative of this first term on its own. So let's work with that. We get our first term, right? Because we have to take the derivative of each term on its own, then use the sum difference rule and put it together. So, because that's what the sum difference rule says, is to take the derivative of each term on its own. So starting with this first term, well, what do we notice? Which rule do we use just looking at it? Well, we got a function divided by another function. So we're going to use the quotient rule. You know, you identify the rule we want to use and then go from there. So here we're going to use the quotient rule. So we're just going to say this whole term is h of x. I'm going to say this x squared plus 3x plus 1. You know, I could have called this t of x or whatever I wanted. It's just, it's arbitrary. So we got h of x and we want to find h prime of x. And we know the quotient rule. So write out the quotient rule. When you're starting off, you want to write these rules out. So I'm going to use the reparameterized version. So we've got u prime v minus v prime u all over v squared. Now, usually we say the numerator is u and the denominator is v. So let's continue. So we have u. So we're going to say u is the denominator. So u is equal to x squared plus 3x plus 1. And we got v. And that's actually, I'm going to write this over here so it's easier to see. We got u is equal to x squared plus 3x plus 1. We got v is equal to x squared plus 2. So let's find u prime. Well, u prime, take the derivative with respect to x. So we got 2x plus 3. And find v prime. So same thing, 2x, right? We just take the derivative. Now put all the pieces of the puzzle together. So what's u prime? So we get h prime of x. Well, what's u prime? Well, looking at, our pieces of the puzzle here, well, u prime is just 2x plus 3. And like I said, put it in brackets when you're starting off. And so now what's v? Well, v is x squared plus 2. What is now we minus, and now we have v prime. Well, what's v prime? Well, v prime is just 2x. And what is u? Well, u is just x squared plus 3x plus 1. And now, divided by, this whole thing is divided by, well, the numerator squared, so v squared. I'm not the numerator, the denominator squared, so v squared. Well, what's v? Well, v is x squared plus 2. And don't forget, we square this whole thing. There we go. We found the derivative of this first term right here. We're done. So there we go. We used the quotient rule. We found the derivative. Not too hard. You just write down the quotient rule, reparameterize, and then, just find the derivatives. In this case, they were really easy. And you just put the pieces of the puzzle together. Read this out in your head. What does it say? What does it mean? Read it out in your head. And it just becomes a whole lot easier. And then at that point, you're just putting things together, just putting pieces of the puzzle together. So let's move on to our second term. So second term, and that's this. And we want to take the derivative of it. So what do we have here? Are we going to use the quotient rule? Are we using the power rule? What are we using? Well, like I said, you need to get good at identifying when to use which rule. And, where are they applicable? Where are they not applicable? And when you're looking here, well, what do you see? Well, you see two functions being multiplied together. Or you could actually think of this as three functions if you consider 2 just to be a constant function on its own. You could say, you got three functions being multiplied together here. So I'm just going to say there are 2. So you got two functions being multiplied together, so we know we got to use the product rule. Now, if I call this, t of x, I'm just going to call it g of x. I'm just going to say, this is g of x is equal to 2x e to the x, and I want to find g prime of x. And, well, I'm going to say u is equal to 2x, and v is equal to e to the x. Now, I'm going to stop right there for a second. Well, we used u and v when we were finding the derivative in our first term. And to make our work more clear and not sloppy, we're going to say this is u1, we're going to go back to our parameters. We're going to say this is u1, we're going to say this is v1, this is u1, 1, and we're going to call these u2 and v2 because we want to use the same parameters, but we don't want to seem sloppy because otherwise we're saying that u is equal to x squared plus 3x plus 1 here, and we're also saying u is equal to 2x. And we want to differentiate between these but still use the same parameters. So we add this subscript. So we're going to say that's u1, u2. So when we're doing the quotient rule, just going back, this is u1, this is v1, this is v1 prime, this is u1, and this is v1 squared. So we're recycling the parameter and reusing it. So we still want to use u and v, but to do that, we're going to add this subscript so we can differentiate when we're using, where we're using it and why we're using it and what equals what. So like, think of it as, being more organized. That's what you're doing. And otherwise you seem sloppy. I know a lot of professors, especially in first year calc, they'll let it slide if you use u and v without a subscript, but you don't want to get that habit because in future math courses, they don't tolerate sloppy work like this. So make sure you put those subscripts if you're recycling the parameter and reusing it. In this case, we are, so let's continue. So we're going to call u2 is equal to 2x and v2 is equal to e to the x, just to differentiate it from our use of u and v when we were finding the derivative of the first term using the quotient rule. So what is g prime of x? Well, we know g prime of x is u2 prime plus v2, times v2 plus v2 prime times u2. So, well, taking the derivative, well, what's u2 prime? Well, it's just 2. Just taking the derivative of u2. And what's v2 prime? Well, that's just e to the x. The derivative of e to the x is just e to the x. It's just itself. So putting that all together, well, what's u2 prime? Well, that's just 2. What's v2? Well, that's just e to the x plus, what's v2 prime? v2 prime is just e to the x. And what's u2? Well, u2 is just 2x. There we go. We got our derivative for our second term. If you want more of a refresher on the product rule, check out my video on the product rule. But here, we worked through it. We found our derivative for our second term. And now we're just going to go to our last term. And we're just going to go on to the next page. Can delete this right now. Or whatever. Let's just do the question. So what was I'm just going to rewrite our whole original expression. So we have y is equal to x squared plus 3x plus 1 over x squared plus 2 plus 2x e to the x minus 1 over x. So we took the derivative of our first two terms, and now we want to take the derivative of our last term. Now, we can take the derivative of either negative 1 over x, or we could just take it of just 1 over x. The signs, they'll balance and adjust themselves out, they'll cancel out, and doesn't matter which one you take, as long as you make sure, you're paying attention to the signs. So, keep track of your signs. That's very important, otherwise you'll get the wrong answer. So what we're going to do, we're just going to take the derivative of 1 over x, and we're just going to, leave the negative out. So let's do that. Well, let's take the derivative of 1 over x. And we did this when we did our power rule. And we know we can write 1 over x as x to the negative 1. And we take the derivative, we bring down the power. So we got negative x to the negative 2. We subtract 1 from the exponent. So that's pretty easy. That's just using the power rule. And there we go. We found the derivative of our last term. But let me show you something else. Let me show you something cool. If we look at 1 over x, we can consider the numerator as a constant function on its own, which it is. So we can consider this as a constant function. And then, we got our linear function on the bottom. So we can see this as two functions dividing each other. So we got 1 divided by x. We got a function being divided by another function. We can look at it like that, and we can use the quotient rule here actually. So let's write down our quotient rule. uv minus v prime u all over v squared, and we can say u is equal to 1, and we can say v is equal to x. And we find u prime. Well, u prime is just 0, because the derivative of a constant is 0. And v prime is just 1, because the derivative of this, x, is just 1. So if you put this all together, well, what's u prime? Well, u prime is 0. What's v? Well, v is just x minus, well, what's v prime? Well, v prime is just 1. What's u? Well, u is just 1. And all divided by v squared. Well, what's v? Well, v is x, and then we square that. And if we simplify this, what do we get? We get negative 1 over x squared. The same thing as that. So we could use the quotient rule. It's a bit of an overkill, but we can still use it to find the derivative of this, because we can look at this as a function divided by another function. So it's a bit of an overkill. There's a few extra steps, so it's just another way to show you that you can take the derivative using this. So now that we have everything, we find the derivative of every expression, so let's put that all together. So I'm just going to erase this. So let's put it all together. So yeah, y prime. So what was our derivative of our first term? Well, it was this, right? So our derivative of our first term, let's put it there. So we got 2x plus 3, put brackets there, x squared plus 2 minus 2x, we got brackets, we got x squared plus 3x plus 1, and we got this all divided by x squared plus 2, put brackets, and we square this. So that was the derivative of our first term. Now our second term, it was just, looking back, it was just this. So we got 2e to the x plus 2x e to the x. And our last term, well, we had minus, and we took the derivative of just 1 over x, and we got negative 1 over x squared. These negatives cancel out, so it's just plus 1 over x. Just plus 1 over x. Done. We took the derivative. We took the derivative of each term, and then we just put it all together, and we use the quotient rule, and we use the product rule. So it's just a matter of knowing of when to use the rules, and just recognizing that if you have a function divided by another function, we use the quotient rule. If you have a function multiplied by another function, then we use the product rule. And we did that here. We looked for when to use each rule. So let's go into our last question. This one's quite interesting. So the last example says we have a function 3x divided by e to the x divided by x sine x. Well, we could actually double apply the quotient rule. We're going to have to double apply the quotient rule here. But I'm going to leave a more complicated question for a tutorial. Because in this question, this question is kind of nice because we can simplify this. We can rewrite this as 3x over e to the x times x sine x. And these x's, they cancel out. And we just get 3 e to the x sine x. So we don't have to double apply the quotient rule here. But we still have to use the quotient rule. So what do we see now? Well, we see we got a function divided by a function. And we're going to call u is equal to 3, which is the numerator, and v, which is the denominator. We're going to say that is e to the x sine x, right? So our numerator is u, our denominator is v. So let's write out the product rule. I mean, not the product rule, the quotient rule. Let's write it out. So we got y prime is equal to u prime v minus v prime u all over v squared. So what's u prime? Well, u prime is 0. Well, what's v prime? Well, v prime, now we've run into something a little different here. So we see that to find the derivative, to find v prime, we have to use the product rule. Because we have a function multiplied by another function, and we want to find the derivative of this. So in this case, we have to use the product rule. And, well, what we like to do in our product rule is parameterize by u and v, but we've already used u and v. So we have to add those subscripts now. So we're going to call this u1, we'll call this v1, we'll call this u1 prime, we're going to call this v1 prime. And we're going to say, well, v prime is equal to u2 prime times v2 plus v2 prime times u2. And what is v2 and u2? Well, u2 is equal to e to the x, and v2 is equal to sine x. It could be the other way around, but it doesn't matter. Instead of putting the subscripts, you could have just used different letters. You could have maybe used a and b, but I like using the subscripts because it's a little more, we still get to use u and v. We get to recycle our old parameters, and it's something more familiar, you know. So to recycle our old parameters and use them again, we want to put these little subscripts down. We want to avoid sloppy work because we could lose marks for that. So we don't want to lose marks for something so little. And I just want you to understand we're doing that because, well, if we say this is u and we say this is u, and we're saying u is equal to e to the x, and then we're also saying u is equal to 3. So to differentiate between these two, we put the subscript there. So u1 and u2 are two distinct different variables, or parameters, you could say. So let's take the derivative. So what's u2 prime? Well, u2 prime is e to the x. What's v2 prime? Well, v2 prime, what's the derivative of sine x? Well, it's cosine x. So let's just put it all together. What's v1 prime now? Well, to find v1 prime, we have to use the product rule and take the derivative of this, because this is a product of two functions. Therefore, to find its derivative, to find v1 prime, we must use the product rule, which we have done right now, and now we just have to put everything together. So what's u2 prime? Well, u2 prime is e to the x, right? So what's v2? Well, v2 is sine x plus, what's v2 prime? It's cosine x. What's u2? Well, u2 is just e to the x. There we go. We found our v1 prime. So I'm just going to erase this. So we found v1 prime. There we go. We finished probably the hardest part of this question, which was to recognize that we had to use the product rule and the quotient rule in the same question. So we started with the quotient rule. You know, we recognized right at the start that we needed to use the quotient rule. We had a function divided by another function. But within that, we also had to use the product rule. And so let's put this all together. Well, y prime, just erase that. So y prime is equal to, well, what's u? Because remember, this is u1, this is v1, this is v1 prime, this is u1, this is v1 squared. So, and that's because we want to differentiate between our use of u and v here and our use of u and v here, right? So, because they're distinct, they're different. So they represent different functions. So let's put it all together. So what's u1? Well, u1 is just 3, right? Put that in brackets. Well, u1 is 3. So what's the next step? So what's v1? I'm going to make this a little clear. v1. Well, v1 was just e to the x. Oh, hold on. I made a little mistake. Hold on. I was looking at the wrong thing. back up, back up, back up. So we're going to restart this. I'm going to just restart this question real quick. Not restart the question, but restart writing it down. So what's y prime? So let's start there. What's y prime? Well, what's our first thing? Well, we need to put u1 prime. What's u1 prime? Well, u1 prime is this. u1 prime is 0 because what's the derivative of u1? Well, u1 is equal to 3 and the derivative of a constant is 0. So we have 0. And what's v1? Well, v1 is e to the x sine x. Then we got minus. Well, what's v1 prime? Well, v1 prime we found right here. This is our v1 prime. We used the product rule to find v1 prime. And what is it? Well, it's this expression right here. So it's e to the x times sine x plus cosine x times e to the x. Put that all in brackets. What's u1? Well, u1 is just 3. Don't forget that. People tend to forget, some of the little things. And you don't want to lose half marks and get the wrong answer because you missed, writing down the 3. So you want to make sure you put every piece of the puzzle in there. So this is all divided by, draw that line again, all divided by what? It's divided by v1 squared. What's v1 squared? Well, what's v1? Well, v1 is e to the x sine x. And to square that, then we just square that, and there we go. We found our derivative. This collapses down to 0. 0 times anything is 0, so I'm not going to simplify that, write it down. So, ta-da, we got our derivative. We're done. So it's a matter of recognizing, though, that we have to use multiple rules sometimes. So here we used both the quotient rule and the product rule. And you will come across these scenarios very, very often because on tests and exams, they want to test multiple rules at once. So they're going to, have questions where you got to use, maybe even 3 or 4 rules. So you might need to use, the quotient rule, the product rule, the chain rule, the power rule. So you need to get a lot of practice with this because otherwise, you're going to get confused at one step and you're not going to know how to get, the right answer. So here we identified right at the start that we had a function divided by a function. So we used the quotient rule. And then within that, we found that we came across a situation where we had a function times a function and we needed to find its derivative because the denominator right here is a function times a function and we needed to break that down and find its derivative, and to do that we needed to use the product rule. So we'll do more questions like this in this tutorial where we're going to be using multiple rules. So we're going to be using the product rule and the quotient rule together, or we're going to double apply the quotient rule like I suggested at the start of this question. However, this actually simplified down nicely, so we didn't have to do that. But we could come across a question where you have to double apply the quotient rule. And, the thing is you just got to keep track of your variables. And that's why we have these subscripts here that, U1 and V1. So you got to keep a track of your parameters. So thanks for watching. Tune in for the other videos because I'll be going over more helpful questions. And, we're really just going to, master this quotient rule and just master derivatives all together, just step by step.